Hey, all right, geometry friends, welcome to our last lesson in chapter 2, 2.6 on geometric proofs. I would like to leave the S off, I guess. Geometric proofs. All right, and this is going to be a little challenging for some of you because it's going to be very new, and I just want to encourage you, take it step by step, pick up what you can, and then just practice, 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 because we'll have more of it in subsequent chapters. And if you don't just shut down and not take the baby steps, concept by concept, you're going to do just fine. All right, so let's dive right in. We've got several definitions, and basically all these definitions are geometric theorems that then you can use as your reasons or your reasons or your justifications within your proofs. And so you're going to want to know these and kind of keep them in your back pocket so that when you're completing a proof and you encounters one of these situations, that can become your answer or your reason for proving something true. So let's just take a look at what some of these are. A linear pair theorem. The linear pair theorem says that if angle A and B form a linear pair, then they're supplementary. So a lot of these are definitions that you already know, but just to emphasize that, it's basically just saying that if you have two angles and you have angle A and B, and you can see there they form a linear pair, they're forming a straight line, then you can always say that they are supplementary, so that A plus B must equal 180 degrees. A and B are supplementary. And so you're going to see certain proofs require you to make one step. Either you know they add up to 180, so you say they're supplementary, or you know they're supplementary, so that you say they equal 180. And if you did that in a proof, linear pair theorem right here, this would be the reason that you would put in your proof. Okay, let's take a look at another one. The congruent supplements theorem. These are all just wonderful names, and just kind of slowly learn them, study them, use your beautiful brain. But it says if angle 1 and 2 are supplementary and angles 2 and 3 are supplementary, then angle 1 must be congruent to angle 3. Right away, just notice this is just before I even draw it, this is an example of the transitive property or the law of syllogism. Or basically you're saying 1 and 2 are supplementary, 2 and 3, and therefore you can assume that 1 to 3 must also be congruent. What this looks like is where if you had these two sets of congruent angles, where you said 1 and 2 are supplementary, see they add up, they're a linear pair, they add up to 180, and say you had another linear pair, and that was angles 2 and 3, well, you know angle 2 is the same. Oops, actually, you know what, and I didn't draw that right, or label it right. Where you knew then that 3 and 2, because 2 has to be the same angle, so that you know that 2 is the same right here, then what does that tell you about these angles right here? Well, it says they must be congruent to each other. So that's why it's called congruent supplements, that if you have three angles that are all supplementary, then the two that aren't congruent, the 1 and the 3, they must be the same. Okay. So, and again, you can see that's just basically a form of syllogism or the transitive property of equality. The next one is the exact same idea, but notice the only change is this word complements. So it's the same idea. We can read it, but it says if angle 1 and 2 are complementary and angles 2 and 3 are complementary, then 1 must be congruent to 3. So same exact idea, just realize it holds true. We have our complementary angles here and here, and if you have angle 1 and 2, you can put a little right angle there. And then if you have another one, but this time it's angle 3 and angle 2, well, you can see if both sets are complementary, meaning they add up to 190, then you can deduce that 1 and 3 must be the same amount, because there's no way they could be different and yet both add up to number 2 and equal 90 degrees. So congruent supplements when it's 180, congruent complements when it adds up to 90. Okay, then we have another one, right angle congruence, and that just says if A and B are right angles, then A is congruent to angle B. And that we can just simply draw that to illustrate what that means, is that if you have two angles and they're both right angles, so here's angle A, here's angle B, if they're both right angles, well, then you can know for sure they have to be the same, because two right angles mean they're both equal to 90, which means they have to be congruent to each other. Okay, so not too complicated, but just to know, it's basically saying that if something's a right angle, it's identical to every other right angle out there, because there's only one type of right angle, that which is equal to 90 degrees. They both equal 90 degrees. Okay, you could also argue that they're supplementary, but. And this last one, the vertical angle theorem. We've already talked about vertical angles. This is just identifying that we can use what we know about vertical angles as a justification in a proof. It says that if angle B are vertical angles, then they must be congruent. So that way, if they tell you something is vertical angles, you can immediately assert that they are equal to each other. Or if you know that two angles are congruent to each other, they could possibly be vertical angles. So there's really not much to say other than the same idea. If you have vertical angles, they are always congruent to each other. All righty, let's start to actually do some of these proofs and maybe see some of this in action, because really it's kind of confusing and difficult until you just start to practice it and practice it and practice it and practice it, which I know you're just dying to do. All righty, well, first a question though that basically asks about what a proof starts with and ends with. Okay, because it's kind of just a tip that every proof is going to start with the same thing, and every proof is going to end with the same thing. And that is, you're always going to start with the given. When you start a proof, you're going to see, as you start to work on them, is that they always give you something to start with. And so your first justification, like your kickoff point, because sometimes the hardest thing on a problem is getting started, is you start with the given. What did they tell you to start with? So you put that down, that's your given. And then the end of the proof, you know you're done with the proof whenever you get to the proof. So with every proof, they're going to say, given this, prove this. Well, make sure your first reason is your given, and your last reason, you know you're done if you've actually finally gotten it down to whatever they specifically asked you to prove. Okay, and then number two is while you're working on a proof, every time you give a statement, and that's in the left-hand column, in the right-hand column, you have to give a reason. You could say justification, but reasons is more support. Okay, shorter word, right? It requires a reason. So every time you want to say something in a proof, you have to accompany it, just like we practiced with the algebra in 2.5, with a reason. So let's go ahead and look at that in action, where I asked you to then solve or work, solve number 3 from page 113. And so number 3, it gives you a proof, and then it says write the justification, just another word for reason, for each step, and then they give you a given. So first off, I'll point out, again, you got your 2 columns. This side, we're going to learn to write an S over top, because that's what we call our statements. Then on this other side, we're going to put an R, because that's where we put our reasons. Now this is nice. Eventually you'll have to do it all yourself, but they've actually worked through it on your own. And so we can see, here's my first given. They are telling us that we have 2 angles, and that angle A is basically half as big as angle B, or angle B is twice as big as angle A. And we have to eventually go down and prove that these 2 angles are in fact supplementary. So I will start with my given up here, and I'll know I'm done when I get down to the given the proof at the end. Alrighty, and by the way, not only is one angle twice as big as the other, they actually tell us one of the angles is in fact 60 degrees. Okay, so let's get started. What's my first reason? Well, my first reason is, how did I know that angle A is equal to 60 and that angle B is twice as big? I didn't deduce that, they gave it to me. So that's why you start every proof with a given. Okay, then we can look at, then they said angle B is equal to 2 times 60. Well, what did they do there? How did they know that? Well, because they had angle B being 2 times A, and they knew that angle A was 60. So what they did is they just substituted the 60 for the A. So that must be the substitution property of equality. So there's my reason. They substituted 60 for A. Then they said angle B is equal to 120. Well, how did they do that? Well, they just multiplied 2 times 60. Okay. Now you might be tempted to put multiplication property of equality. Because we multiplied. That's not what you actually put in this case, because you did not multiply both sides by a number. We didn't multiply both sides by 2 or both sides by 60. we just simply did what this step, this is a new one, this is called simplify. Whenever they just work out some of the arithmetic on one side, you can simply say your reason is you're going to simplify. 2 times 60 is simplified to 120. Alrighty. Then they said angle A plus angle B equals 60 plus 120. Okay, well, how did they do that? Well, they simply used the addition property of equality, because you can see that they had B equals 120, and then they added the same thing onto both sides, which in this case was they're adding the fact that A equals 60 up here. They can say, okay, so that means I can add A, which is 60, and I can add 60, which is the same as A, and I'm not really changing the equation. So this is the addition property of equality, because they are adding the same thing to both sides. Okay, because A and 60 have already been established as being equal from the given at the top. Alrighty, so we added something to both sides, so addition property of equality. Then how did they get from A plus B equals 180? Well, same thing as when they multiplied the 2 times the 60. They just did arithmetic on the right side. They did 60 plus 120. So we can just call that simplify. They just did math on one side, arithmetic on one side. Okay. And then finally, how did they get from A plus B equals 180 to that they're supplementary? Well, if you think about it, that is the definition of supplementary. That the definition of supplementary angles means they add up to 180. So whenever you jump from a definition to what the definition means, or the meaning of a definition to the definition, that's where you can just put, this is the definition of supplementary. That's how they knew. How can you know that something, when you add them together, they equal 180, that means they're supplementary? Well, based on the definition of supplementary. Okay, so there it is. They gave us all the statements, and we had to supply the justifications or the reasons on the right side. Now, again, if your head's spinning, don't panic, because again, if you're not used to this, you might be thinking, how could I ever do that by myself? Well, frankly, I would say you can't. You're not used to this. You're just learning it. You just need to practice them again and again, which is why I'm making these videos to help you learn. So don't give up, and check out the exercise video for help on the actual exercises for 2.6. You can do it. All right. See you soon.